Thank you, Alexandra. Good afternoon, everybody. It's great that you're all here. I'm excited for the next 2 hours, and I really appreciate you coming in. I want to start off by saying that this is going to be, a bit of information. It might be a bit foreign to a lot of you, but I'm really excited to introduce maybe a new concept, maybe a new software to everyone here, and open up the possibilities for this new mode of visualization. And I just want to start off by saying if anyone has any questions, or if anyone wants to bring up anything, I'd encourage you to use the raise hand function in Zoom. We're gonna take a few breaks and a few pauses throughout the session so that I can open up the floor to any questions and I can voice any concerns. Also, I just wanted to ask, maybe by a show of hands, or if anyone wants to respond, how many of you downloaded Blender? Great. So I know Adam has Blender, so Adam will follow along. And okay, so I guess that's great. So maybe we can start off by actually going through introducing myself and a bit about my motivation for doing this. My name is Mohamed Ashraf, and I graduated from Tandon School of Engineering with a master's in the Management of Technology degree in 2020. And after that, I moved to Montreal and started up my own startup called Omic, and it leverages a lot of technologies from a lot of different universities, notably from Rutgers, and it involves headphone technologies. So what we do is we enable certain features within headphones, and that's really exciting. But one of the issues that I faced is that I had trouble effectively communicating what we can do. And that's when I picked up Blender, and that's when I understood how powerful of a tool it could be. Because learning Blender and spending 2-3 weeks learning the fundamentals and developing an animation so I can put it in an investor pitch enabled me to, without using as many words as I can, communicate just how valuable our innovation is, and getting the message across. And you can tell when you give pitches and when you talk to a room full of investors, especially ones that are prone to interrupting you, just how powerful a slide is, or just how powerful the message is when everyone is speechless. And I can tell you by experience that me and my co-founder found everyone was speechless when they saw the animation. So I'm hoping by the end of this course that I can provide you with the same tools that I learned, hopefully condensed, or at least the seed or the inspiration to kind of go off on your own and explore this very valuable skill. So without any further ado, maybe we can start off by going through the UI of Blender, how to navigate things, what the key functions are, and what you get when you first start off with Blender. Once again, if anyone has any issues or any problems, I would be more than happy to have you use the raise hand function in Zoom, so that we can address these concerns moving forward. Hopefully, there shouldn't be too much. I also want to mention, last thing before we get started, that I think Alexandra sent over a resource pack for everyone. What this resource pack contains is a number of Blender files, hopefully for those of you who have Blender, so that you can follow along at certain key points within the progression of what we're going to do. And so the idea is that I've broken them up into certain key fundamental concepts within Blender, within making an animation. And if at any point within developing this, if you're following along, which hopefully you are, you're effectively lost, or something happens, or an issue comes up because of your machine or because of the type of version of software that you have, you can just pick it up in the next stage. So hopefully that's the idea behind those different Blender files. And definitely I'm going to mention them and I'm going to refer to them moving forward. Now, maybe we can talk a bit about Blender and what we aim to achieve and what we aim to do throughout the next 2 hours using this tool. So Blender is effectively a 3D modeling and animation software. It's open source. It's written on Python. The motivation behind it was for anyone to actually use certain industry level tools to create great animations, great visualizations, great games. It's used a lot within the industry for both VFX, for manipulation of images, and for 3D modeling animation from making games to making short movies and videos. So this is what you get when you first click on Blender. You get this view, and what you can start off by doing is clicking on General, and you get a cube. So this cube is actually, it's an image burned into my brain right now, but it's what you start off with, and depending on the hardware you have, depending on the mouse that you have, you can zoom in and you can zoom out by scrolling, and you can actually hold the scroll button and orbit around like this. And if you hold Shift, then you can pan left and right and up and down. Now, if anyone's following along and wants to do this now, feel free to do so. And if there are any issues, then we can quickly see what's up and whether there's any differences. But I also want to say that this is heavily dependent on your hardware. So there's going to be a lot of variation here, but I hope that it's not too much for you not to follow along. Now, what you see here is the object mode, and you can see it on the top left here. And object mode essentially outlines the different holistic monolithic objects that you have. You can control the location of them. You can also control the rotation of them and their scale. You can control the relative positioning of different objects, and you can see where all these objects are from a hierarchical view up here on the top right. This is called the scene view, and it illustrates certain collections. Now, when you start off with Blender, what you have is light, a cube, and a camera. And the reason why you have a camera is because of, like I said, animation purposes. Whether you're rendering an image for promotional sake, or whether you have an animation and you're going to move this camera around. This camera is one of the most fundamental objects within any Blender project. And views are really cool because what you can actually do is click on view and then find different ways to navigate using a viewpoint. I know that a lot of you might not have numpads. So even though I do, I'm going to generally remember as much as possible to navigate to other views using this function, just so I can remain as standardized as possible. So the first one is camera, and this basically shows you what the camera sees. This is going to be very useful later when we're focusing on animation. But for now, this is fairly cool. What's also very useful is going on either a top view here, a front view, or a side view. Since it's a square, there's going to be significantly no difference at all for the cube, but you get my idea. So let's orbit back, and now let's think about the different processes we want. So the first thing we want to do is, once you have Blender open, is, well, we don't want to keep modeling. We want to start off by asking ourselves a few key questions. Some of the questions that we might ask ourselves are, essentially, what's the message that I'm trying to get across? If I'm using Blender for a specific project, for a specific animation, or if I'm doing something, that's going to take up a bit of time. It's going to take up a bit of resources. So I have to ask myself what the cost benefit of this is. The idea behind Blender is that it communicates key technical concepts or key concepts in general. It promotes something and it showcases something. So the message and the innovation that you're trying to communicate has to be key, has to be core. It has to be worth the time you're going to spend and worth the learning. So the important questions are, what's the core of the innovation? Now, I know a lot of Tandon alumni have invented a lot of things in the past, and a lot of people have trouble communicating these things. But an invention and a product are two different things. The core of the innovation is really what you want to drill down on, really what you want to showcase, regardless of what it is, regardless of what form it's going to take within the market. And the next question is, how can I showcase this innovation? What's the best way to showcase it? Now, this can lead to different things like your user journey, like maybe a product, a final product that this innovation is going to be embedded into. Now, I know that for Omic's case, we are licensing our technology for headphones. So at the end of the day, I'm animating a headphone. And what that means is that this is the focus of my animation. It's not our technology, it's what our technology can do using headphones. So maybe I can actually shed some light on it by showing the video. Sorry. Let me. Nope, not this one. Apologies, everybody. So this is one of the first videos that I had, and it's quite rudimentary as an animation, but it gets the message across. When someone has headphones on, what we do is enable a heart rate, and ultimately we can measure that without having a user wear a watch or wear any other device. Now things have progressed and my animations now look much better, but ultimately this was enough to get a conversation started, to get people interested, and to get the message across. And this is kind of what I'm talking about. The idea that all you have to do is keep it as simple as possible. You have to ask yourself why you're doing this and whether it's worth it. And once it is, then we can move on to the next part, which is what can it look like? Now you can tie this to the product. You can tie this to the user journey. In our case, what we're going to be doing today is we're going to make, for example, a robot arm that's going to pick up one beaker and move it to the other beaker, pour something, and then move it back. Now, maybe we can skip and take a look at the animation. Just so you have an idea of what it's supposed to look like at the end. Here we go. There's a robot arm here, and there's one beaker and another beaker. Now, this might seem daunting right now, but I don't want anyone to feel like this is going to be hard or it's going to take a lot of time. It's going to be easy because I've done it before. So once we have those questions answered, and once we understand exactly what we're going to do and how we're going to communicate it, then we can go on to the next part, which is sketches. Now, I want you to imagine for just 1 second that we are on a piece of paper. When I say sketching, I don't mean having a work of art that you can display on the mat. When I say sketching, I mean having something very rudimentary that is going to enable us as designers, as modelers, to visualize exactly what we want to do. And it can be as rough as a circle drawn by my mouse that illustrates a base, for example. And for example, the first link here, and then a joint. I'm hoping we all know what a robot arm looks like because we may have run into one during our time in Tandon. But if not, then I'm going to draw one now. I don't want anyone to think that this is representative of every robot arm out there because it's a very rough drawing and it's very messy, but it is enough to get the point across. And the audience here is you. You are your own audience at this point. So you can make it as messy as you want because you do know exactly what you want. The idea here is to communicate to you, but it's also to ground your ideas. Now, a lot of times you can think that you want this and you want that and you want the whole world and all the bells and whistles. But ultimately, when you trim it down and you draw and you sketch and you take out a pen and paper, you find that you can get the message across in a much simpler way without having to model 100 different things. And this is the real value of sketching. The real value of sketching is giving you a framework and a foundation for later. Now, I'm brushing across this now, but this sketching process can take a day, 2 days, even a week. especially if you're collaborating on this with other people. And a sketch doesn't just have to be from one side. So what we can do is actually move to another viewpoint, maybe the top viewpoint, and now we can actually place the two beakers, one here and one here. So if we want, for example, this robot arm to move, pick up one beaker and move it to the next, you can imagine what kind of innovation this communicates. Maybe there's a liquid in this beaker that reacts with another liquid here and glows. Maybe there's a gas in this beaker and a solid here, and once the gas hits the solid, it sublimates. No, I don't think it sublimates, it melts into a liquid. It can be anything you want because these are all numbers at the end of the day, and you're the one giving the commands. So the sky really is the limit. And as exciting as that sounds, it's also quite dangerous because you can imagine a lot of different things, and realizing them means that you run into something like scope creep, for example, where things just get out of hand, or you face limitations with computing power or with Blender, for example. And so you have to balance out what you want to communicate, how fun you think this is going to be, and how much time you have. And speaking of time, we can skip on to the next one, which is modeling. So now that we have our sketch and now that we have a general idea of what we want to do, then we can go on to the next viewpoint. And once again, feel free to raise your hand if there are any questions. If not, then we can move on. Front, and we can model. Now, when it comes to modeling, we can actually explore a lot of different features that Blender has to offer. The first being actually let's move on to a box select here. And you can always go back to annotating or measuring or box selecting again. But we can select this cube and we can press delete. Or actually, we can right click and we can delete it from here. And the reason why is because we can now add an object like a base, for example, here. And this base is a mesh. We're going to talk about meshes shortly. And this is a UV sphere. And so let's just zoom in here and pan. Now, this sphere is a mesh. It's one of many meshes that Blender has to offer. And a mesh is just a collection of points that have coordinates and have relationships to other points. And this enables us to have a representation of a mesh as a 3D object within a 3D space. So every point has attributes like the location on the X and Y and Z coordinate, as well as its relationship to other points. And each point has an identifier. That's how they know what's connected to what. Now, meshes have to do with something called topology. And topology is basically how your object is shaped and what the array of meshes and the organization of meshes looks like and how clean it is. Now, I just butchered the definition of topology, and feel free if anyone has a better one to chime in. But this is ultimately everything I need to know to make a good mesh and to make a good Blender object. So for the sake of the UV sphere, you can see that every mesh is well organized, everything is connected the way it's supposed to, and there's a well-rounded flow of the meshes. And we can see that even more prominently if we switch here from object mode to edit mode. Now this actually highlights every point, as well as every connection from one point to the rest. And we can select by point, 1, 2, 3, and we can manipulate point by point, which gives us a much higher level of control on this edit mode as opposed to object mode. And it also allows us to shape this sphere the way we want to. So I'm just going to box select half of all the meshes. And actually, you know what? Let me click on this first. And this you can tell here. So this really cool thing about Blender is that it actually pops up an explanation of whatever button you're hovering over, which makes it really easy and really user-friendly, especially for beginners like me. And you can target X-ray. And what X-ray enables us to do is see everything and select everything. So you can tell before I had X-ray on, if we orbit, I only selected the first half because X-ray was not on. So Blender could only see the first half. But now that now that X-ray is on, I actually have the luxury of selecting every point within this downwardmost hemisphere of a sphere. And we can delete these vertices. And the reason why I want to delete them is because I want to make a face here. So let me select all of these points as well. And if I orbit, I can actually see, or I can visualize what shape this face, this new face that I'm going to make is going to take. Blender allows you to remove and add faces as you see fit, provided that it assumes you have good judgment of what topology is. It gives you errors if it can't calculate or if it has a hard time understanding what the topology you're trying to do is. But for the most part, if we give enough thought to every action we do, we can effectively get away with a lot of different things that don't seem right at first glance. And let me remove X-ray mode. And you can see that by selecting all of these, Blender calculates that it assumes that I want a face that connects all of these vertices together. And the best way to do that is to just make a planar face that connects the southern hemisphere. And this is going to be our face. So we can go back to front view, and we can do something even cooler. We can actually toggle X-ray again, and let's select. Actually, you know what? If you go on select and you go on circle select instead of box select, it'll give you a really nifty feature where you can highlight all the different vertices that you want. So we can do that. And then we can actually get introduced to a very, very useful feature of Blender, which is the grab tool. Now, for grab effectively means that you're grabbing whatever you're highlighting and you're moving within space. It's a transformation of coordinates. And if I press G for grab, you can see that Blender knows that I want to move these spaces. So let's say I grab and move down. You can see that it's a bit wobbly because it depends on my own mouse movements, and they're not perfect. So I can actually limit my movements to a certain axis. If I press X, then it limits it to the X-axis. If I press Y, then it limits it to the Z-axis, which is effectively nothing because right now I'm facing the Z-axis. It's pointing out of the screen. But if I press Z, then this gives me a bit of what I want. I think this is good. But now that it's also highlighted, I can take advantage of another function, which is to scale in and out. So you guessed it, it's S for scaling. So if I press S, this gives me a very great level of control. And once again, for S, if you press Z, it snaps the scaling to the Z axis. Same thing with X, and same thing with Y. But right now, I don't want to snap. So I can just miniaturize the scale on all axes. And I think that's good for now. So if I go back to object mode, let's see what this looks like. Yeah, I think that's great. And I think the last thing I want to do is add a modifier. So a modifier, you can think of a modifier as the Instagram filter of objects on Blender. And what that means is that you can add a specific envelope of effects within an object. And I think for us, subdivision surface looks good. But let's increase the viewports just a bit. I think that's good. I think the last thing that I would do is maybe flatten this out. I don't like the way this looks. It looks like a flying saucer, to be completely honest. So maybe I can press Control R. And Control R is a loop cut. And what a loop cut is it's a way to effectively subdivide a specific segment or a loop of segments within an object. So if I do a loop cut here, Blender does a really useful feature, which it allows me to actually drag the loop cut and identify where I want it to go. And so I can actually make a loop cut and drag it all the way to the bottom here. And then if I go back to object mode, yeah, I think this looks better. Let's toggle off. Okay, maybe I can take a chance now to open up the floor to any questions anyone has. Great. Great, no questions. So maybe we can move on. So I'm going to do the same thing again for the first joint. So I'm going to, and actually G for grab is something you can implement an object mode too. So I just press G and let me move this here. And same thing with S. You can scale up and down, actually. And you can find the transform tab here, and it shows you everything you need to have. It gives you a lot of granular control over the X, Y, and Z coordinates, the rotations, as well as the scale and the dimensions. Dimensions are incredibly useful if you have something like a technical drawing, or if you're making a feature or a product or a component that's supposed to fit into another part. So let's scale this down. And you can tell this is very heuristic in nature, just by the mere fact that, you know, I'm going based off looks, based on how I feel, how this looks. Not really going based on any technical or physical constraints, just because I have that power, I have that luxury to do something just because it looks good, you know. And this is an animation at the end of the day. It's not supposed to be representative of anything other than the value added or the innovation that you're having. But you also have the freedom as the creator, as the inventor, as the innovator, to make this as lifelike or as realistic or as detached from reality as possible. The only limit now is that you have to explain yourself. So that's something that it's honestly a judgment call at this point. So I think this is good. Maybe I can add something else, which is the arm. These are all meshes, by the way. Each one of these is an individual mesh that we can actually go across with. And I just press G so that I can grab it and move it. And you can tell that even though the sketch is quite rough and it's quite childlike in nature, I am following it, and it does help. And next we can rotate so that I wanted to take kind of this angle. So we can actually rotate using the transform tab, or we can rotate by pressing R. So if I press R, the cursor automatically changes to indicate that you are in rotation mode, and it tells you exactly, or it gives you an idea. You can see on the rotation tab the number on rotation along the y-axis, what type of rotation you want. Maybe I can give it a clean 45 degrees. So the good thing about Blender and the rotation tab is you can kind of have a coarse idea of what you want things to look like, and then you can go back into the rotation tab, the transform window, and you can actually hone down on a number, maybe a number that you remember, a number that looks good to you, a nice clean number, just for reference sake. And then you can scale this. So I just pressed S, and the cursor changed once again. And again, I'm scaling down on all axes. So every certain dimension is being scaled by a certain factor. And you can tell on the top left, where it says scale X, Y, and Z, that all three scale factors are the same number. So this is a ratio of the dimensions you have versus dimensions that exist right now. And the ratio is supposed to be consistent for uniform scaling. Now, what we can do, and I'll show you this later, is we can actually control that number, but more importantly, we can scale along the axis, just like grabbing and rotating. We can limit ourselves and constrain ourselves to a certain axis. That gives us a higher level of control. So let's scale this down. It's 0.27. So we can actually scale again. We can limit ourselves to the z-axis, x-axis, y-axis. Or we can highlight a certain vertex. Actually, let me go to edit mode. Let me switch on X-ray. Let me select these vertices and let me grab them. Let me do the same thing for these vertices. Sorry. Okay. Now we have the first arm. And one tool that's going to really help us keep track of everything is if we effectively rename a lot of these objects. So we can rename this joint 1. And we can rename this arm 1. Or actually link 1. And let's press on joint 1. So one thing that's very useful is a copy-paste function, like for text, for example, but for objects. And Blender knows this. So it actually developed something called holding shift and pressing D. Or if we right-click, we can duplicate the object. And duplicating the object automatically lets you grab it and move it to another place, which is what we're doing now. So we can do the same thing we did for the first joint for the second one here. And we can actually do the same thing that we did for the first link for the second one. Then we can go ahead and press R and rotate it once again. Press G. And here we are. Second link. Link to joints. Now, one really great thing about this view is that it allows you to look at potential duplicates, like one we have right here. So if I click on joint 1 and joint 2, you can tell that there's a overlap. And if I press G, yep, so this is a loose duplicate that we don't need. I just deleted it, and it's something to really take care of because this is something that can come back and bite you moving forward. If you're animating, if you're rigging, if you're keyframing, this is something that's that you need to really be aware of in the future. So let's shorten this a bit. Go into annotating. And you know what, never mind. It's not important. So if we duplicate this once again, for the last time, we can duplicate this too. Here. You can actually press R, rotate it. And press G and move it. Just to make things look a bit more realistic, we can actually make this a bit smaller by pressing S, and then we can go to edit mode, select these vertices, and move them a bit further down here, so things can look a bit more grounded. go back to object mode with this over here. And I guess we can do the same thing for this one. Press G, move it a bit more. Just so things look more grounded. And what's nice about Blender is that you can actually select multiple objects and then grab them by holding Shift. If you select something, hold Shift, select something else, now you have both objects, and you can apply certain transformations, like if I want to rotate them, or if I want to grab them, or if I even want to scale them up. And then you run into things like where's the scaling point, what's the ratio, what's the origin, but these are things that, they're more advanced. So now that we have all three arms and we're renaming them, we can move on to making the hardest part of any robot arm, which is the end effector. It's the thing that's actually going to grab onto. Actually, one important thing is we need to save this. So let's save this as robot arm. I just pressed Control S, by the way. Robot arm. .blend. Saving it in my Blender file, my desktop. Saving is really important because Blender has a tendency of crashing, especially depending on your machine. So saving with almost every function is a habit that I painfully had to get into throughout a lot of lost hours over the years. So let's Control S again. Now for the end effector, what we can start off by doing is duplicating a joint, moving it here, and then going to the top view. And maybe scaling this a bit down. And then adding an object that looks closest like the end effector we want. So if you remember, orbit back, we wanted something that looked a bit like this, like a claw almost. But we also want it to be horizontal because it's going to be picking up the beakers. I actually have a beaker here. So if my claw is vertical with the beaker, then I'm going to have a hard time picking it up. But if it's horizontal, then it's much easier for me to pick up, and it's much easier for me to model if I'm doing it on Blender. Same exact concepts. You think about what looks more realistic, what looks more lifelike, and it'll make our lives much easier if we go on the horizontal. So in the spirit of that, I'm going to go to top view. I am going to add a cube. I'm going to move it close to the end effector, but I want to snap to the x-axis just to make my life easier. And usually when I'm in doubt and I don't know what mesh to pick, I start with a cube or a circle and I move my way up from here. And this is a very good example of kind of making it up as you go along, but not really, because you're following a loose plan. So we can scale that just to what we think it might look like as an end effector. So maybe something like this, and this can actually be the center of our end effector. And the two claws can actually branch out from it. So how do we do that? We can switch to edit mode, and now we have control over the different vertices. And what's really great is you can actually, within edit mode, apply a modifier called mirror, which makes you guessed it, mirror an object along another axis. So here it is. Here's mirror right here. And you can test that mirror by selecting a vertex and just grabbing it. So it's mirroring along the x-axis, but we want it to mirror along the y-axis, I think. Yeah. Yeah. So if we highlight this move it up. So you can tell already that things are going a bit well. So what we also want to apply is clipping, something called clipping. Now, what clipping does is, if you move past this axis, it clips. It essentially crops anything that goes past the mirror axis. And we can also merge. And what merge does is that it assumes that anything within a threshold of, in this case, 0.01 meters is the mirrored object. So they're merged together. This adds a lot of cohesiveness to the object itself. So I highlighted these. I'm going to move them in the y-axis until they touch. And now they're clipped and they're merged. So Blender thinks they're all one object. Blender shows them as all one object. Now let's highlight this, and we can press something called, actually, yeah, we can extrude. Sorry, no. Let's not extrude the vertices. Let's do something else. So the entire time I was on edit mode, I was selecting vertices. But Blender gives you the option to actually select edges as well as faces too. The reason for that is, it's more freedom and it makes applying or modifying meshes easier. In this case, I do want to select a face. And you can switch between selecting vertices, edges, or faces in the top left, right next to view, which I'm coincidentally going to click so I can move to the top view again and extrude. Now, the reason why I want to extrude this face is because I actually want to make it curve like a claw. And so I'm going to also press R so I can rotate this face and then extrude once again. I'm going to rotate once more and extrude. Finally, one last time. Rotate. And then extrude. Let me go back to vertex select mode. And let me scale this, actually, just to make it look a bit more like a claw. Highlight this as well. Scale it. And I really don't like the way this looks. So let me highlight it. And I can grab, just to make it look a bit nicer and cleaner. And then let's save, of course. And one last thing we can add is, actually, you know what? Let's switch back to object mode first. And let's move this here. Let's scale it. So I pressed S, and then I limit to the Z axis. So it looks a bit more like a claw. And then we can push it a bit into the joint. Hello? I don't know if you can see me or hear me, but I think Blender crashed. I think, oh, great. Thank you, Desmond. Okay, so Blender crashed, which is something you can do. And It's a good thing I saved. Let's see how much I saved. Okay. The chat's saying you can see me and hear me. So thank you for that. Thank you. Thank you. Okay, great. So this is why I talked about saving and how important it is, because I would have lost the arm. And it's, in my opinion, a great looking arm. I think I like it, and let's keep on going. Let's press G, limit it to the Z. Let's see if this is going to work again. And save it. And then let's scale just on the Z axis. And I'm a bit worried, but I have to press forward. Okay, great. Whew, passed it. Let's go on the top view. Let's move this on the x-axis. I just pressed G, everybody. Okay, so I think this looks good. One thing I would like to do is make it look a bit more organic. And the way to do that is to add a modifier called subdivision surface. Now, I think we talked about this with the base, but let me just touch on it again. It subdivides mesh into smaller and smaller parts. And this is a really, really useful modifier. Maybe the modifier I use more than anything else. It's the modifier that makes things look more organic, look more flowy, and just essentially look cooler, especially when you're modeling people or characters or fingers or anything like that. A subdivision surface essentially makes the mesh look much cleaner, much smoother, and much higher poly. Higher poly means how many different points or polygons you have. Much higher, much higher definition, without actually adding that much more. So it's a great trade-off. It's a great tool. It's very useful. And you can see just how many subdivisions you make. So right now, it only subdivided once. And if I zoom into the plot, you can see that before, and I can actually switch it on and off. You can see that right now, let me actually close X-ray 2. Right now, it's harsh. There's 90-degree angles. There's a lot of different edges and things like that. And once I turn on subdivision, even if it's just subdividing the one time, it's a game changer. It makes things look cleaner. If I make it twice, it looks even cleaner and cleaner. Let's bump it up to 4. And maybe that's why my Blender keeps crashing. Now you can actually outline and see where there's different parts and problems in my mesh. So I can go back to edit mode, and understand and ask myself, why these issues happen. A lot of times, this issue can happen when there's more than one vertex in the mesh. So maybe, maybe I can highlight this. This is a quick fix. It's one of the easy ones you can do, and go to vertex and see if I can merge them. Can I merge them? I can merge them at the center. Press M, merge again. Wow, it seems as though this is an issue. So we can actually get around this by just dissolving this vertex altogether, or even deleting it, maybe. Oh, here we go. So the issue is fixed. It seems as though there was a loose vertex somewhere, but now we're good and we can press on. So now we have our general model. We have, oh, here we go. There's another one. Well, no problem. We fixed it once, we can fix it again. Press G. Let's delete this vertex. Here we go. So are there any more? You know something? A way to actually hone in and magnify and just isolate the object is by pressing the /. And / is a really, really great way to, yeah, it's on every keyboard. It's not just the ones with the numpad. So I just checked. The / is a really great way to isolate this specific thing. I think another one you can do is, yeah, local view. Apparently it's called local view. Who knew? Well, I mean, a lot of people knew, but I didn't know. So now I found out. So thank you for the opportunity. Thank you for the learning opportunity. And we can clean this up really quickly by deleting this. And here we go. We have a very clean mesh. It looks cool. It looks smooth. It's subdivided. It's great. Let's go back to object mode and let's go out of local view. Toggle local view. And now we can see that we have a clean robot arm. Now, how do we make it move? That's a very good question. Let's save first. And that's when we introduce rigging. So now that this is gone, we can actually remove the annotation layer and just stick to the box select. And rigging starts with an armature. And what an armature is it's basically a bone. Blender thinks of it as a solid object that connects to another object that connects to another object. You can think of it as a macro vertex that has motion and follows dynamic rules. So, sorry, apologies, everybody. I'm just increasing this so I can see if anyone has thumb up. I have a second screen, that's why it looks like I'm looking away from the screen, but I'm actually just looking at you. And yeah, apologies. Actually, you know what? Maybe we can stop here and see if anyone has any questions to do with modeling. I know I went a bit fast, but I just want to make sure that everything is covered. So feel free to have a thumbs up or just talk if anyone has any questions. If not, then we can move forward.
Just a general question. When using these animations in our projects, do we need to give some acknowledgement that this was done in Blender?
Acknowledgement that it was done on Blender. So acknowledging the actual software, it's open source, so no. But I would check the Creative Commons licenses, and I would check if, for commercial purposes, if you're selling a certain software, then that's a different ballgame altogether. But if I'm using this to showcase to certain investors, it's not really a commercial purpose. It's more of a demonstration or a showcase. So I'm not selling this video. So no, I don't need to acknowledge Blender, but I would have to check with a lawyer if I'm making a video to sell to someone else commercially.
Yeah, makes sense. Thank you.
No problem. Any other questions? Great. Let's move on to rigging. So the way to rig is to start off with an armature. And the way to do that is to add an armature. Okay, and Blender added it for us at the center of, and you can tell it's the center by this white and red circle. Center of the screen. Let's toggle X-ray just so we can see it better. And we can treat an armature just like any other object. We can go to front view and press G so we can move it. And then we can go to edit mode and move the end of the armature. So the armature has two different properties. It has the beginning and the end. And the reason why there's an end is because usually the configuration is a parent-child configuration. So the first part of the armature is the first parent, and then there's a child, which is essentially a parent to its own child, if there's another link, and so on and so forth. So this armature is a parent armature, and it's going to represent the first link. Now, if I move this to press extrude, I can move this to the second joint, which represents the second link, and so on and so forth until I reach the end. And here I have my robot arm. Essentially, I was going to move my robot arm. We can take some time now to actually click on this and clean up our selection process just so we can make life easier, because we're introducing a lot of cool things right now and we don't really want to confuse ourselves. We can call this end effector. Great. Okay. Now, a big question is, oh, here we go. Go back to object modes. Okay. Let's go back into edit mode. Actually, we can go into, yeah, edit mode. So a big question is, how can I make this move? And with a robot arm, I don't know if anyone has seen robot arms move, even in movies, they kind of move a bit organically. They move X, Y, they move with joints. And this is representative of real life. When you're making a robot arm, it's not like, for example, you have your own arm and you look at something and your brain calculates exactly where it's supposed to go. If I'm picking up, for example, my camera, it's different for a robot. For a robot, it's rotations within a specific motor, because that's essentially what actuates the movement. And so there's a lot of different math that has to be calculated. And the thinking process there is more trigonometric than it is heuristic. Rather than for human beings, for example. So the way to represent that is through something called inverse kinematics. So inverse kinematics is something that I spent a lot of time in undergrad trying to understand, and then realized that I can do in Blender in 10 minutes without any math, which is great for everyone because it democratizes a lot of different concepts that are technical in nature and that don't need that much trigonometry. But the fundamental bare bones concept is, let's say, for example, you see an object like this camera, you want to grab it, but you need to calculate every angle and how much it's supposed to turn. So instead of doing that, you start inversely from where the camera is. So you understand the location of the camera and you work backwards to, this is my end effector, this is my first link, this is my joint, this is my second link, this is my second joint, and so on and so forth until you reach the base. And that gives you an idea iteratively of where every position, every joint needs to be. Blender does this really, really fast. And this is something we're going to use now to make animating this much, much easier. So the first thing we need to do is actually identify an object for this arm to follow. And this object is going to be another armature. So if we press extrude here, and we can make this armature whatever we want it to be. And this is going to be an independent armature with no parent that we can actually use to control where this arm is moving. This is really cool. I mean, when I figured this out, it was really great. If anyone's following along, you're in for a treat right now. So let's go on to the first link. Actually, let's take some time right now to name these things, to name this bone. Maybe it's edit mode. Oh, you know what? They're already named. Oh, great. Thank you, Blender. Bone 1, bone 2, bone 3. Yeah, that's easy. Okay, great. So you can tell here what the bone group is. So let's go on to this one. It's connected. The parent to it is bone number 1 here, and it's already connected. And the same thing for this bone here. The parent group for it is bone 001, and it's also connected. What we're going to do is change this. So let's remove this. I think it's or maybe actually it's an edit mode. Yeah, here we go. Here we go. So if we go into edit mode and just press X for the parent, then you can see that it's not connected anymore. And you can actually verify that it's not connected by pressing G in gravity. You can see that it's not moving. It's not connected to anything, it's moving freely. If we press escape, then we can keep it, and we can actually rename it here. IK, that's for inverse kinematics bone. And you know what? Let's actually name every one of them. Let's name this link 1. So it can correspond with what we're used to. Spawn 1, I mean, it's kind of generic. Link 2 and link 3. This will make things much easier. Okay, so if we go back into pose mode, and these are all different ways or different perspectives to see the same object, which is this armature. Go back into pose mode, and we click on this tab here, bone constraints properties. We can add a bone constraint. Oh, you know what? We can add it to this one actually, link number 3. And we can add an armature constraint. Oh, no, not an armature constraint. Inverse kinematics constraint, sorry. Apologies. Is it? Oh, yeah, armature, sorry. Let's click on here, select the bone group, inverse kinematics bone. Okay, and if we've done everything right, then what we find is that if we move this bone, actually, interesting. No. Oh, maybe it's not. Maybe it's, oh, I'm sorry. It's inverse kinematics, it's not armature. I'm sorry, I was thinking of something else. I really do apologize for this. Target now is armature, it's inverse kinematics. And okay, now if we've done everything right, then we can find that, oh, the arm is moving with respect to the object. Blender is very quickly calculating where every position of every arm or every bone exactly has to be, so that the end bone, so the actual bone with the constraint in it, can position itself to be touching the target object, which is the inverse kinematics bone. So we've successfully achieved inverse kinematics in the 3D modeling software, which is going to be very easy to convert that into an animation moving forward. So if anyone wants me to actually repeat this last process, feel free to do so, because I mean, I recently learned this, so there was a lot of trial and error in the past, and I understand if anyone wants me to do this again. So feel free to do so, or to say something if you want me to repeat it. If not, then we can move forward. Great. Let's move on. So now what do we have? We have a really cool model that doesn't do anything, and a real cool armature that doesn't render. How do we link them together? That's a great question. If we go back to object mode, we click on this link right here. So this is link number 1. I have time to make all of these things, or expect things to follow along. That's a great question, Desmond. Maybe do you want to expand on it? You can talk. Anyone can talk, by the way, if you want. Desmond? Okay. Oh, no problem. No problem. It's okay, Desmond. It's okay. If it's too much work, then that's really what the point behind the resource pack is. It's that I have stages with initial modeling, final modeling with rigging, so the armature, for example, and other parts moving forward. And what you can do is either follow along, or if you're right, it is too much work, but you can follow along at certain points. You can also keep the resource pack for future reference. Again, Alexandra told me that this is going to be recorded. I know that this is recorded right now. So the idea behind this is that it serves as a primer. So it's recording available to us, so we can make those. Of course, yeah, of course, completely. The resource pack is available to you. The recording is available to you. Blender is open source. All of this is open, and you can use it and open it, experiment with it whenever you want. You can also make mistakes, and you can feel free to contact me. Anyone here can feel free to contact me whenever they need to, and I'll be more than happy to go over any of the issues that you're facing. I know that Blender is a complicated software, and it doesn't run the same on every machine. It doesn't run the same for everyone, and the exact process can be done multiple times in multiple machines in multiple days and end up in different results. So this is an exercise in failure, if not anything else. There's a lot of things that I failed in doing while preparing the resource files. There's a lot of things that I failed in doing now. There's a lot of things that I might run into during the next hour. And there's a lot of things that I'm going to run into that I'll fail at doing in the future, my entire journey in Blender. Same thing with you and same thing with everyone else. And so I think the most important part is to understand what you want, know what you want, and be comfortable knowing that it's going to take a lot of failure to get there. Because at the end of the day, I mean, I didn't just, know how to do this. I've done this before, and I'm still coming up with difficulties, pressing wrong buttons, even live here, and it's recorded. So it's on the internet forever. So I think Desmond and Bruce, you guys bring up really good points. This is a lot of work. It is condensed, but at the end of the day, it's not a body of knowledge on its own. It comes with resource files, and it comes with me. So this is just supposed to get you excited. It's supposed to show you the possibilities of Blender and give you a brief overview of all the cool things that it has to offer. Great. So are there any more questions? Desmond. Sure, I think, yeah, okay, great. Yeah, no, what have been your favorite use cases of 3D modeling in the field? I guess inverse kinematics. I don't know if it's a new toy that I'm playing with now, but I think it has a lot of potential. Simulation too. Unfortunately, I'm not including simulation here because I barely know how to do it, so it wouldn't be right if I teach you something I just have a surface level knowledge of. But I think simulation and inverse kinematics, Blender has a lot of possibilities in actually communicating just basic physics and basic solid mechanics, basic mechanical concepts, basic electrical concepts. Right now, I'm working on with a startup, making them a video for an antenna technology that they have. And the thing about communications and electronics and antennas is that you can't really see the electric field. You can't see the signal. So it's very hard to demonstrate what the difference between conventional technologies and innovative technologies are in a domain where everything is invisible effectively until you see the end result. And you measure latency, and if it's less than 1 millisecond to the general public, that doesn't make a difference. But for someone who works in, for example, Industry 4.0, who knows that that means hundreds of thousands or millions of dollars annually in savings, then you can talk to them. But those are few and far between. So having, when I work with them and when they tell me, we need a video to showcase what antennas right now are sending out and what we can do, then that's one of the great use cases, because it can do something that you can't do in real life. It can communicate invisible things. So when I said the sky's the limit, this is what I meant. you imagine it, even though you know it exists, you imagine it, and you visualize it and you show it to people, and they go, oh, okay, now I get what's so impressive about this innovation. Now I get why it's so cool. Now I get why you're asking for X millions of dollars. Yeah, sure, I'll do it. So I think that's one of the most important use cases. It's connecting the dots between someone who's in the industry and someone who has a very, very deep level of knowledge about a technology, and an investor who listens to hundreds of pitches, or the general audience, or a customer who doesn't have that deep of a level of knowledge, who's heard of these concepts before, but isn't expected to visualize and understand what's going on and what the impressive incremental innovations are. And so once you connect those dots using a visualization, then you hit the money. Then that's your, that's where you hit gold. I hope I answered your question, Desmond. Okay, no problem. Okay, so maybe we can go back to connecting the links, the 3D models to the armatures. Here's what we can do. We can add another constraint. So constraints are effectively their limits, their design limits and their motion limits that you can apply to a model to make it follow something else. So this is one of the great constraints when we're talking with armatures, and you can actually add a constraint to this object with a bone, and press link one. To be honest, I don't know if this is going to work, but let's find out. Actually, sorry. Oh, here we go. Okay, great. I genuinely can't believe that worked. I mean, I spent a lot of time trying to figure out how to make this work, but apparently, yeah. So I don't know if everyone followed, but we're going to do this 2 more times so we can follow then. So the idea behind this and the motivation behind this part is that when we select the armature and we move it this way, the problem is that there's no connection between the actual model that we have and the armature that we developed that has inverse kinematics and all these cool things. And what we want to do now is actually make that connection. We want to make the robot arm that we spent a lot of time making look really cool, going on edit mode, standing up, and all that stuff. We want to link it to this physics-bound inverse kinematics dynamic system. And the way to do that is adding constraints, like I said before. So if you select an object, like the link, for example, and by design, we started off, and this is why planning is really important, because if you know that you want to move this robot arm, you'll make an armature that's within the same position, that follows the same path, that has the same, general shape. And so it's not that too much work to actually make a connection between one thing and another thing that are in the same position, especially if it's a geometric connection. So again, we're going to select the relationship. The definition of the relationship is armature, simply because we're connecting an object to an armature itself. It's a bit in the name. We add a target bone, and a bone is just one section of the whole armature. So we named them, but we can, and there's only one armature. So the selection, when we click here, it's the number of armatures, and then we can go into further detail and see which bone within that armature do we want to relate to this object. So number 2, and we can verify. Let's save right now. Verify that we actually made that connection by going into pose mode and moving. Yeah, here we go. You'll notice that the joints aren't connected yet, just because I wanted to test out everything on the links first. It's just easier to visualize that way. But we can just as easily link the joints as well. Let's do it for the last one too. Armature, add target bone. select the armature we want, select the link that we have, and let's verify. Here we go. Great. I don't know about you, but this is pretty exciting for me. Now we can, I have a bit of confidence, so I don't want to sound too cocky, but I'm just going to add the constraints and verify at the end once all the constraints are done. Sorry about this. I'm speaking to my future self. If I run into any problems. Okay, add target bone, armature. I'm going a bit fast and I apologize, but if anyone wants me to stop and take a breather just so you can catch up, if you're following, feel free to do so again. And if anyone has any questions, then please feel free to ask again. I know Bruce and Desmond, thank you for the great questions, as well as Maria. Thank you, all three of you, for the great questions. And I'll be happy to answer any more. Save. Okay, moment of truth. Oh, look at that. That's just great. You know what we can do? We can do the same thing for the end effector. And here we go. So now I think everything is going well. Yeah. So now we have a robot arm, everybody. I'm very excited about this. And I mean, this looks great. Now, we want to make animations. So let's introduce the concept of keyframing. Actually, before that, let's introduce the concept of adding models. So in Blender, a lot of things you can model yourself, and it's very fun, but you're not expected to model everything. And people have modeled things before. What's even better than doing things yourself is taking other people's work. This goes back to Maria's question of, other people have modeled other things, other Blender files. How do we use that? Is it okay to use it? And it is perfectly okay to use it, depending on the license. There are some licenses that are open, Creative Commons license, for example. There are some other licenses that are not used for commercial. And it's going to be a case-by-case basis. So it's up to you, and it's a judgment call as to what type of license this person is applying to their body of work and how you can comply with that. Now, sometimes it's going to be very obvious. Other times, it's not. And feel free to reach out to any of the people that made these models. Chances are that they're going to be very friendly people. I mean, this community is great. It's how I learned everything I learned. That's how I'm planning on learning more. I have a lot of faith in the Blender community, especially because they're very supportive. And it's all based around open collaboration and creativity. So there's other options where you can get Blender models for money. So you can get paid Blender models. So these are more extreme. These are things that will cost a bit more money. But sometimes it will be easier to pay because you're not really paying for the model, you're paying for the time that you're saving by not making this model yourself. So again, like I said, it's a judgment call, and it depends on how much you need this technology, how much you need this model, and what you need it for. So either way, what I'm going to show you right now is a way to actually import different Blender models into your existing model. First thing I'm going to do is save. I'm going to get out of pose mode, and the way to do it is to click append here. And so within the resource pack that I've provided, we actually have the model that I want. It's a model that I made myself. So I'm giving you open license to use it in any way you want. This is recorded, so there's a record of me doing it. Feel free to use it. It's a blender, it's a beaker. So let's click append, and this is going to show you what a Blender file consists of. It consists of every attribute or every piece of information that relates to a Blender file. Brushes, where the camera is, what the collection is, a lot of different things. But what we're interested in is the object, specifically the cylinder. I didn't call it beaker, unfortunately, but here we go. So you can see it on the center here. What we can do is switch to top view and press G and actually move it. It's a bit bigger than I remember, smaller than I remember. So maybe we can scale it up a bit. We can press S and we can effectively make it a bit bigger. Actually, we can press a bit more S's. And here we go. Now, what we can also do is duplicate it. If you remember, well, what I wanted to do is actually I wanted to make an animation of a robot arm picking up a beaker and pouring it onto another beaker and then dropping it again. We can very much do that, but for that we need two beakers. And unlike real life, we can just duplicate things without having to worry. I'm going to press Y so that I can limit it to the Y-axis. This is going to make life easier in the future because then we only have to move the robot arm on the Y-axis as well. And I'm going to save. Now, pre-orbit here. Now that we have all the models that we need, what we can do is get introduced to the animation parts of it, the time aspect of it. So this is called keyframing. And keyframing effectively enables you to, enables you to set certain points where you want an object to be within over time, and that leads to motion, just like in real life. So we move on to keyframing, and if you just click on this tab here, you'll see that these are the number of frames you have. So by default, Blender gives you a 24 frame per second timeline. And you can actually modify that by going on this tab on the right and clicking on output properties, render properties. Output properties gives you a lot of these things. The frame rate, here we go. It's by default 24, like I said. We can actually bump it up to anything you want, including custom. So it's up to you. What this is going to factor into is the render time. So the way Blender renders animation, actually the way anything renders animation is frame by frame. You move one frame to the next and your eye sees motion. It's I think it's persistence of, I don't know. I think it's persistence of vision, but I'm not sure. Let me switch on the map. Sorry. Persistence of vision, I think it's called that. But yeah, so we have 24 frames per second and we have the start frame and the end frame. So this animation is going to end at 250, but we can actually make it end at 480. Just because I've done it before and I know how much it's going to take. And if you scroll down or up, it zooms down and up here. So one of the key concepts of animation is that you want to compartmentalize things. You want to make sure that you have an idea, you have a vision of what things are supposed to look like and how they're supposed to move in your head. And then you want to break that down, whether through writing or just if you want to keep it in your head, if it's short like this, into what every object is supposed to be doing. So you have a core object and follower objects. In this case, obviously, the core object is the robot arm. So we can start by animating that first. And then we can make the beakers follow along. So how are we going to animate the core object? Well, we can start off by introducing this as the first keyframe. So the way to do it is to just hover over the location, press I, or hover over it and insert keyframe. You can insert keyframes for each one. And then go on to pose mode and do the same thing. This is quite tedious, but I promise you that it's worth it. Sorry. Now, let's say, for example, after 2 seconds, the robot arm moves towards the beaker. So let's go to 48 frames, which is effectively 2 seconds. And you can do a viewpoint. We can move it over here. Or we can just insert the keyframe. Insert the keyframe again. And go to object mode and do the same thing. Well, I guess we don't have to. Pose mode. And then after another, maybe 96 seconds. That's another 96 frames. So it's another 2 seconds. You can press G to grab and then move down the Z axis. Grab it like this. And press G again. And move it on the X axis for grabbing it. And insert another keyframe. So let's make sure that we're doing things right. Here we go. Great. So far, so good. This is a very good validation step. It means that our keyframes are working. Everything is working out the way we want it to. And the way to actually visualize how the keyframes work and what everything looks like is to go into the animation and click on graph editor. So this effectively gives you a graph of the motion paths, the values over time of every specific parameter. So if you open up and drop down, you can see X location, Y location, the color coordinated. You click on one and you highlight it. So it's a very, very granular view of what everything does at a high level. It's very, very useful. It's very powerful. So it's picked it up. Let's say it takes maybe 3 seconds to pick it up. So if we do some basic math, from 96, you add 24 times 3. That's around, I don't know, 72. You add that to 96, that's 168. I think, I hope. I graduated from Tandon. I'm supposed to know this. Actually, you know what? There's no shame in using a calculator on your phone. Let's do that right now. So 24 times 3, 72, plus 96, 168. I'm so proud of myself. Okay, 168. Let's say that within those 3 seconds, we give the end effector enough time to actually grab onto the beaker and situate itself the way it needs to. And so after 3 seconds, we move up. Actually, let's say, let's press escape. Let's go back. Let's say you have 1 second. So after 96, you have, I think 24 would be 120. Yeah. And I'm just pressing the right key, the right arrow key, which makes me move frame by frame. You can effectively say that we have 1 second for the end effector. While I was saying it, I thought this is not going to take 3 seconds, it's going to be boring. So you have 1 second for the end effector to close and clamp down on the beaker. Then you can insert those keyframes. So now we know that, and now Blender knows. Actually, we're telling Blender that at frame 120, we want this location to exist. Why? So that at frame 168, which means that 2 seconds later, it can start moving. Within those 2 seconds, it can start moving from this initial position to a final position, which is lifting up the beaker. Let's grab this. Oh, for a second there, I thought it crashed. That's interesting. So for some reason, my keyboard decided to switch off. Let me switch it back on again. Oh, here we go. Okay, that's great. Okay, so we're back on pose mode. We're on 168. Let's grab this, press G, put it on the Z axis. Actually, no, it'll be easier. We select this. If we simply move it up like this. Oh, no, sorry. Yeah. Oh, never mind. Let's just grab it. Z axis, move it up. This. And we can insert the keyframe. Okay. Great. Oh, I'm glad that made you laugh. Thank you. Thank you for that. And now that we've lifted up, imagining lifting up the beaker, we can actually move it after this keyframe. We can actually move it after maybe, I don't know, 2 seconds. So let's add to that 168 using my trusty calculator another 48 seconds. 216. Great. So at 216, what we want is to move this, and we can actually go to viewpoint. The top view is to move this on the y-axis here. And this is why I said it would be very useful to actually move it just on the y-axis, because now all we have to do is move the arm on the y-axis as well. We don't have to worry about the x-y coordinates. We don't have to, consider that an issue. We can insert another keyframe, and then we're effectively pouring. So let's pretend that it's pouring. It's pouring for maybe, I don't know, 3 seconds. So let's add another 72 frames. It's 288. And then we can insert another keyframe because it's still, this whole time it's still, and then it has to start moving. So we think of animation from start to finish, not just where we want it to be, but how it's supposed to start and how it's supposed to end for every motion. And that's one very hard issue. It's a very hard paradigm to shift to when you think about animation. You think about loops, you think about, I want it to move from here to there, but when you break it down to the fundamentals, everything has an initial position and a final position. And that's why, and each one of those is defined by keyframes. So keyframes are your best friends after Control S. You have to save everything. I just saved right now. Let me save again. So in another 2 seconds, so we add another 48. We do 336. And I, again, encourage everyone to ask as many questions as they can. Feel free to do so. I would love to answer any questions you have. We can insert the third keyframe.
And what are you pressing to do that insert and mark those positions?
Oh, the keyframe?
Yeah.
Oh, that's a great question. So I just go on the location and right click And I
Ah,
just insert the keyframe.
okay.
Yeah. Yeah. You can also press I. I was going to make things much easier. In general, shortcuts in Blender make things much easier in life. So I will insert the keyframe. If you insert the keyframe and mistakenly insert it, you can press Alt. So you can hold Alt and press I, and that will enable you to remove the keyframe. So this actually brings me to a very good point, which is, let's say, for example, that you messed up and you want to change things after frame 232. So a great way to select keyframes after that or before that is to actually, instead of highlighting everything, because you can be zooming in here and you wouldn't know that there's other parts below and above. And if you selected multiple parts, then it might get complicated. So you can actually make life easier for yourself. So you can go and select and go on anything after the current frame. And this will just enable you to highlight any frame, any keyframe after the frame you're on right now. Same thing with before. So you can select all the keyframes before the frame you're on right now and delete them, move them up, move them down, speed them up, change their intensity, whatever way you want. So this actually makes life much easier. It doesn't seem like something is effective, but it's one of your best friends. It's one of the best tools when you're animating. So maybe we can go back and see what it looks like. Actually, let's pick a better view. You can go back here. If you press space, just like on YouTube, it presses the video you make. Picks up the beaker, moves it over here, and it pours, 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 and then it moves it back. Okay, now after 336, let's say it takes us maybe 2 seconds, another 2 seconds to move it down and drop it. 384. Let's go back 384 and drop this down. Press G and then we press Z so we can constrain the movement to the Z axis alone. And insert the keyframe. Thank you for the question. Your name says Del 3847, but thank you for the question.
Yeah, I haven't figured out how to get it to change my name.
Oh, it's cool. It's cool. Maybe after Blender you can learn that. But okay, so once we have that, we can actually spend one more second, plus 24, 408. And one last thing we can do is click on it, press G, constrain it to X, and then just remove it and gently drop it down. So that can give us our last keyframe for the actual robot arm. Now we have to ask ourselves, what else do we need to animate? Well, first thing that comes to mind is the end effector. So how do we link the end effector to whatever is going on? Well, like I said before, you have to have a core, a key parent with other childs for the animation. So the key parent here, the core of the animation is the robot arm. So let's see what the robot arm does at specific points and how the end effector can enhance or add to that animation. So first it moves above the beaker, then it closes in on it, and then it moves into it and picks it up. So this is where our end effector really has time to shine, when it picks it up. Because how is the robot arm supposed to pick it up? Using those claws. And those claws can move back and forth because we designed them to. So one of the easiest ways to do it is to actually go back and let's click here and see where, if we press down and up, you can skip, you can jump to keyframes, which is very useful. But if not, then we can just zoom in and go to, so on 48, it's right above the beaker. Then it moves all the way, let's save this first, all the way to 96, I think. And I think that's where we can start. So let's go into object mode and select this object. And this is our initial keyframe. Starts initially, press I, insert keyframes, and this is where we start. So what do we need to do? We need to actually close in on the beaker itself within that time. So between 96 and I would say 120 is a great time to work at. So let's say between 96 and in between those two, there's, I think, 24 seconds that we can play with. No, there isn't. It's just 24 seconds. So I think there's 12 seconds that we can actually use. We can actually go into 120 and define what the final position is. And we can let Blender interpolate how the motion is supposed to look like. So the question we have to ask ourselves is how do we realize having an object close in on a beaker? I think the best way to do that is to actually scale it down. So if we go into view mode and go to viewport, no, not front, I guess it would be top here, we can actually, because I keyframed scale as well, we can actually just press S and limit it to the y-axis. And that can approximate a jaw closing in on something else. If we insert this keyframe, then we have what we need. Let's see how this looks like. Yeah, I think that looks good. Oh, but then there's this. So we have to modify it to make it look like it's pouring. And I would say we can synchronize it with existing keyframes. 2216 is when the arm stops and gives the clock time to pour. So we can insert keyframes here as well. Let's say let's add the scale. And let's see how long it takes. Okay. It goes all the way to 288. So the in-between is where we're playing. Let's give ourselves, let's say 216, let's give ourselves 12 seconds to rotate everything. I think that's a good time. So 216 plus 12 is 228. And we can start off like this, and then we can select object, and let's rotate it. So let's rotate it along maybe the x-axis. See how this looks like. Yeah. A little bit more, 110 sounds about right. And let's insert this keyframe. And it goes all the way to 288, if I'm not mistaken. So we can actually go back 12 seconds before that, which would be 276. Insert a keyframe. I'm out of caution inserting keyframes for location and rotation. I know I don't need to, but I've learned a long time ago that I can't trust myself to keep tabs on every specific keyframe that I have. So I just keyframe everything and clean up everything afterwards. Now we can reverse this rotation. Go back to 0. Insert a keyframe here. Let's do this one as well. And let's see how this looks like. Goes in, grabs the beaker. Oops. Oh, wow, that's a lot. Okay, so clearly this scale is a lot. So let's say, for example, I don't like how fast it's going and I want to extend it to double how much it's going for right now. We can do this. We can go for X rotation. And this identifies and highlights where exactly this rotation is. and we can go for that. Let's zoom in. And what you can do is you can actually press G, just like it's an object, and move it. So if I press G, I can move it. And if I constrain it to the x-axis, then I can move it along the time. It's weird, I know. But if I also press 12, then I can extend it 12 more frames, which means that instead of having, for example, 12 seconds to do it, it has 24. Same thing with this, where it rotates back. If I can do this instead of, if I press G and press X, so I can constrain to the x-axis and then press 12, but then go negative, then it also elongates the reverse process. Press enter. Now we can see what it actually looks like. That seems more natural to me, I think. So the one last thing we can do with the end effector is actually, let's go back here. And I wanted to let go of the beaker. So the way to do that is, let's save. First things first, save everything before it crashes. And then do the same thing we did last time, which is scaling. So I scaled it. It actually doesn't matter. Here we go. Let's stick to what we know, the parent, and let's see what the keyframes are here. Here we go. We have this keyframe. So this is where we drop everything off. And this is what we have to work with. We have, I think, 24 seconds. Yep, we have 24 seconds. Yeah, we have 24 seconds. So we can start with 384 and we can move for 24 frames, sorry, and we can move for 1 second to let go. If we go back to edit mode, or sorry, object mode, click here, we can insert the first keyframe, the initial position for location, scale, and rotation. Then we can actually move to the second one, which is, was it 408? Yeah, 408. And scale up. Same thing we did last time, but in reverse. If we scale, press S and then limit to the Y. That's a keyframe that we can insert. Okay, I think we're done with the keyframing of the, oh, it crashed, I think. Yeah. So I don't know if anyone can see me on Skype, sorry, Zoom, but my Blender just crashed. I apologize for that. Oh, here we go. It's not responding. Let's close the program. Yeah. The chat is, I just got something on the chat. We see, okay, thank you, Desmond. Okay, so it crashed. Yeah, save. We have to save everything. We have to save everything. But it's a good thing we saved because now we can just stop. And I even remember it was 384. We have this, it's an object mode. I'm just going to speed run this if you don't mind. And then you have 408. Okay. So what do we have? Grabs on, picks it up, moves it to the other beaker, pours, reverse pours, puts it back, expands. Yep. Okay. Last thing we need to do for the animation, alt loops, is the beaker. We need to make the beaker get picked up. How do we do that? Well, we can animate it as well, but an easier thing to do is to add a constraint. So what we can do is actually think it's armature. I hope it's armature. It might be armature. It is armature. Great. But in the beginning, it's 0. Okay, so maybe I can just brush. I'm going to go over this. Oh, no. No, it's not armature. I think it's something else. I remember it being. Actually, never mind. Yeah. Oh, it is. It is. It is. It is. Clamp to. Actually, you know what? It's a great thing to do. It's to actually go here. See what I did. So I've already done this. Like I said, I failed a lot, and I've already done this. So what I can actually do is I can go onto the existing constraints, and I can see what I did. I did a hook. Okay, great. Let's open a robot arm. Okay, we're good. I know what I'm supposed to do. Everyone's great now. We have 5 minutes left. So all I'm going to do is this, and then I can open up the floor for questions. So let's go into. Also, if anyone wants to ask me questions now, to move the beaker, could you copy the movement of the arm to the beaker? Yeah, so I can, but I have to synchronize the movements very well, or else there will be relative motion or jitter. What would be much easier is to actually have a relationship between the end effector and the beaker. So I can effectively emulate a physical collision or a physical connection between one surface and the other. So that's great, but A, that would take a lot of time. B, you have to be very careful with the keyframing and the motions if you want to make sure that everything looks natural. What I'm going to show you is a way to actually not have to worry about keyframing when it comes to the beaker, because the beaker is effectively a passive object. It's being picked up. It's not actually being actuated. It's not moving itself. It's being moved. So that's a perfect use case for something called a hook. And a hook is something I've used extensively recently when you're following one thing with another. So you can do that with, it's like a hook. It's like you're hooking onto something. So you're moving when it's moving and you're standing still when it's standing still. So Bruce, that's a great line of thought. And I really like that question. And I actually tried it. I mean, this is exactly the first thing I tried. I mean, you're right. Like I tried the exact same thing. Okay, let's see. So we applied the hook. by effectively highlighting all the vertices and then selecting this so we can establish the relationship and then saying we want a hook. And it's a modifier, it's a modifier, which means that we have to switch to object mode if we want to see it work. Here we go. Great, that's great stuff. So it's being picked up. So Bruce, you'll see exactly what I mean now. It's not moving on its own, it's being moved, which is actually what happens in real life. It's being rotated, It's being rotated back. The problem is we need to fix is that there's obviously distance between them both, but more importantly, it's scaling as well. And we don't want that. So here's what we can do. We can actually wait until it's done scaling. So we can, as a keyframe, we can keyframe the strength. So the influence that a modifier has. And I know that we have 2 minutes left. Apologize for this. I think I went over, so I am sorry. We can stop right here if everyone wants, but I can also keep going. I don't know what the plans are, so I'm yours. Do what you want with me. We can stop here if everyone wants. Alexandra, I don't know what the protocol. Keep going. Okay. Thank you, Bruce. I love the enthusiasm. Okay. Anyone who needs to go, feel free to go. It's perfectly fine. I think Alexandra has already shared or will share my contact information. Feel free to.
Yeah. So what I'll actually do is I will send this recording to everyone who registered, whether they arrived here or not. And what I can do is I can end the recording now. But if you want to continue on with a small group, that's perfectly okay as well.
Yeah.
Did you want me to end the recording now? And then you guys can just kind of have a private Zoom?
I mean, that works. I don't know if you have to end the recording, but it's up to you, Alexandra. I don't know if you have to be here to have the recording done, or if there's something that we have to do. But it's up to, honestly, it's up to you. I'm free to. I think it's going to take a couple of, 10 minutes, 15 minutes maximum.
Okay, I'll keep the recording. You said 50. If it's 15 minutes, that's fine.
Okay. Okay, sure. Yeah, so the resource packet has been saved. It's also linked. It's the first message on the chat. There's a link to the resource packet. It's a Google Drive link. Feel free to download it. Also, I think this recording, I think Alexandra mentioned that it will be provided to all of you. So yeah. Okay. So like I said before, we can influence the actual strength of the modifier that we have, and that could be a keyframe. So that's a factor that's time dependent. So we can actually wait until the end effector is done, and I remember it's 120 frames, and then we can go back 2 frames. We can go back actually 1 frame. Why not? No, you know what? We can actually start here. We can have 0. We can insert the keyframe, and then we can go the next frame, and then we can add 1. That way, okay. Yeah, I think that works better. I think there was an issue with the keyframing, but we can work through it. It wasn't saved. Yeah, so we can have 1 here. Insert the keyframe. That way. Oh, you know what's happening? It's actually moving the beaker instead of the section. Okay, so instead of me troubleshooting this, let's actually end it. Let's end the recording. Alexandra, we're actually over. So let me end this. There's a working file in the resource pack, and I can actually send this finished file too. So that way, there's two different ways to actualize this. Or you know what? Let me show you what it's supposed to look like. I think that's the best thing to do. Yeah, let's save it just in case. Yeah, so this is what I wanted. You actually pick this up. Let me this rigid body constraint just so I can move faster. So you pick it up, and it's a bit choppy. And then you move it. And then you pour. So it rotates. And this is what I mean by a smooth transition or a smooth relationship between the end effector that's supposed to pick up something and the beaker that's supposed to be picked up. And you can see that the beaker, if I press on it, the only keyframes that it has are the strength of the hook itself, which you can see here. I can just this are the strength of the hook itself. So these are keyframed, and you can tell that they're keyframed by it being 1 now and then moving to 0 once we hit, I think, second number 338, I think. So if I just go back, you can see the transition between it being affected by the object and then it being let go and just dropping back to its initial position. This is as lifelike as I can get it, personally. This is all on X-ray, but I think it looks great otherwise. Oh, I'm sorry about that. I think it looks great otherwise. Maybe one last time. Here we go. And if you see what it looks like when it gets picked up, it's again quite natural and lifelike. Okay, I think one last thing that I can do is show you what this looks like as a render. Because a final product is really what's going to showcase this technology. So if we go back to the camera, and if we see essentially what it's supposed to look like, we can add another window right here. This is a trick that I like to do, where I add another window that's also a viewport, and we can change the view to a camera view, like I said before, and we can move the camera back and forth. Based around essentially, what we want to do. So this is what it would look like if it was picked up. And then if we save this and then press render, we can see what the actual objects, what the materials look like, what the lighting looks like, and it gives us a much clearer view of what we're presenting. So I think this looks much better as essentially as a showcase, as a way to show your product. And when you render the animations, it takes a lot of time because this is done, but this is one frame. We have 480 of them. But it gives you a much better idea. And so just to show the progression and what it's supposed to look like, and an idea of the changes in the growth that you can experience if you go through Blender and if you embark on this journey, I can actually show you another animation that I have, which looks more into the effectively the ideas that I have and the you know the innovation, you know, and what it looks like. Sorry, I think no, it's not this. It's actually, yeah. So this is a showcase of our first product ever, and it's quite a short video, but having this as an opening really shows the commercial value of what your innovation, what your startup can do, or what your company can do. And you know, the ideas, you know, they can move more and more forward, and they can look a bit more complicated, but these are just some of the opportunities and some of the things that you can bring and value you can bring to a company and to yourself if you choose to actually, you know, learn these things and implement them and realize your imagination. So yeah, I think there was a lot of material to cover. I'm hoping that a lot of the material that we weren't able to fully cover, you can embark on yourself. I'm hoping the resource packs and this video was a good stepping stone or a good seed for you to go on your journey. And once again, I'm available, and I would love to have a chat and see what you can all come up with on your own if you choose to learn more and more about Blender. So thank you very much. I apologize for going over. And if nobody else has any questions, then I guess I look forward to seeing what you got. Thank you, Bruce. Thank you, Desmond.